Gonna start the second video, which is spiral 3. Let me see if I can get it. No, not here. And this week. Okay, here we go. May has 15 oranges, 9 peaches, 18 pears. She wants to put all of the fruit baskets in baskets, with each basket having the same number of pieces of fruit in it, without mixing the fruit. What is the greatest number of pieces of fruit May can put in each basket? So she doesn't want to mix the fruit. So in this case, we can still do this. 15, 9, and 18. It's the greatest common factor, so 3 goes into 15 5 times. 3 goes to 9 3 times, and 3 goes into 18 6 times. So remember, but this one's a little bit backwards. Okay, she wants. I'm assuming, if I understand this question correctly, without mixing the fruit. So the baskets are not going to be mixed. Okay, so with the 15, this is oranges. This is the 9 peaches. Alright, PEA, and pears. Okay, which means you can make greatest number of pieces she can put in each basket. The greatest number is going to be 3. So for the oranges, she's going to make 5 baskets. 1, 2, 3, 4, 5, and she's going to have 3 oranges. 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. With the peas, okay, she's going to make 3 baskets. 1, 2, 3. And you're going to have 3 peaches, 3 peaches inside. Okay. And with the pear, she's going to make 6 baskets. 1, 2, 3, 4, 5, 6. And you're going to have 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3 pairs in each. So notice that in this case, this is not the number of baskets, but in this case, this is the number of fruits. And these over here are your number of baskets. Okay, so it's a little bit backwards on this one. Just going to have to read the question a little carefully. Okay. Bus A leaves Main Street every 24 minutes. Okay. Bus leave every 42. It is 1:30 right now. Both buses just left. When will both buses leave Main Street at the same time again? So it just left. You just missed both buses, and or you just missed both buses, I guess. And so it's an LCM problem, because it's something, 2 things that are repeating over and over and over again. One at a 24 rotation, and the other one at a 42-minute rotation. But at some point down the line, they do meet. So 2, that's okay with me. 12, 2 is 21. Let's use something higher. Well, 3 goes 12, 6 times? No, 4 times. 3 goes to 7, 21 times. And 3 goes 27 times. LCM, because you can't go anymore, would be these 4 numbers. Times. 4 times 7 over here is 28. 28 times 3. 24 is 64, 84. Okay. 3 times 24, carry 2. Yeah, 84. And 84 times 2 is 168. So in 168 minutes, both of these buses will be at Main Street, leaving at the same time again. And 168 minutes is, well, 1 hour is 60. Another hour is 60. So that would be 120. So minus 120 gives me 48 hours. So I know the 168 minutes is 2 hours, because that's 120, and 48 minutes. So let's add that to 130. Okay, so it'd be 2 hours and plus 2 hours and 48. So let me add 130 plus 2 hours and 48 minutes. Well, let's do the 2 hours. So 1 o'clock plus 2 hours is 2 o'clock, 3 o'clock. That'll make it 3:30. And then we're going to add 48 minutes. 48 minutes, I can break it up into 30 minutes and 18. So I know that 3:30 plus 30 minutes is 4 o'clock. And then 4 o'clock plus 18 is 4:18. So next time, both these buses will leave Main Street at the same time. It's going to be 4:18. Prime factorization of 420. 2 and 210. 2 is a prime circle. 210, I can do 10 and 21. Sorry, I'm not going to circle that. 10, I can break it up into 2 and 5. And now I can circle because they're both prime. 5, And 21 is 3 and 7, and that's prime. So 420 can be written as 2 times 2 times 3 times 5 times 7, which is 2 to the second power times 3 times 5 times 7. Okay? Exponential form, expanded, it's 4 times 4 times 4 times 4. I know that's 4 times 4 is 16, 16 times 4 is 64, and 64 times 4, 16, 2, 56. 1, 2, 3, 4, 5, 6, 7, 8, 7, 8. So it's 1 to the 8th power, and 1 times 1 times 1 to 8 times is just 1. 1600, what number multiplied by itself can give you 1600? Well, I know if I took these 2 zeros out, it would be 4 times 4, and adding those 2 zeros gives me a hint that it's a 40. Okay, 0, 0, 0. And that, the expanded weight would be 40 times 40. And then using the distributed property. Okay, now this one has a letter, a variable. It's called a variable. Get used to it. You're going to see a lot of that in your near future. So how do I multiply when it's a letter? 4 times k, I can write it as 4. And I'm multiplying k. K represents a number that I don't know. So we can just go and say 4k. And leave it as 4 times k. That's my first. And then I'm going to do 4 times 2. It's 4 times 2, and then let's subtract that. Right, so it's 4k times 4 times 2. Or if you want to simplify that, you can 4 times k stays as 4 times k, minus 4 times 8 is 8. So there's your expression. Okay. At the bottom, 12 plus 50 equals, so let's find something that's in common between 12 and 50. What's the greatest number that can go into 12 and 50? Let's do, and we can do it. That's the GCF. So 2 goes into 12 6 times, 2 goes to 50 25 times. Can any other number go into 6 and 25? No. That's it. That's the GCF. So 2 goes outside. Inside I put 6 and 25. Let's see if that's true. 2 times 6 is 12, and 2 times 25 is 50. There you go. So those two expressions are equivalent. Is that it? No way. Oh no. Okay. So model 5/7 divided by 3. Oof. Model. Okay. So I'll try to make it pretty. 5/7. Let's draw 5/7. So 5/7 would be something like this. 1, 2, 3, 4, 5, 6, 7. And out of the 7 pieces, I will shade in 5. So 1, 2. Okay, so represents what I have, 5/7 or something, okay? Right there. And I want to divide this by among 3 people. So I have 5/7 of something, and 3 people are going to share that. So the easiest way, I think, would be to cut this into 3 parts. So let's cut this like this. And that goes to person A. All these pieces go to person A. Now cut it again. And that goes to person B, this row here that we just created. And person C will get all these bottom pieces. Everybody getting the same amount. So how much did each person get? So if I have 5/7 and I want to divide it by 3, each person would get, let's see, 1, 2, 3, 4, 5 pieces. Right? They would get, and B would get 5 pieces, C would get 5 pieces, at a total of how many? Well, it's 1, 2, 3 here, and 1, 2, 3, 4, 5, 6, 7. 5 out of 21. Remember, even these count too. Okay, so the answer is 5 out of 21. Find the product. Find the problem. Oh boy. Okay, here we go. So I'll do that here because there's more room. 19.33 times 4.63. I know that this has 2 decimal places and this has 2 decimal places. So my answer is going to have a total. Remember, you have to add this 4 decimals. Okay. Let's start multiplying. 3 and 3 is 9. 3 and 3 is 9 again. 27 carry 2. 57. Before I start my next line, I need to add a 0. Okay, let me shift things over. And then 6 times 3 is 18. Carry 1. 6 times 3 is 18. Again, plus 1 is 19. Carry 1, 6 times 9 is 54. Carry 1, no, carry 5. 6 times 1 is 6, plus 5 is 11. And then we're going to add 2 0 before we start multiplying the 4. So we're going to go 1, 2, and now we can start multiplying the 4. 4 times 3 is 12. Carry 1, 4 times 3 is 12 again, plus 1, 12, 13. Carry 1, 4, 9, 36, was 1, 37. Carry 3, 4 and 1 is 4, plus 3 is 7. That's how I would do it. So 9 and 8, 17. Carry 1, 10, 19. Carry 1 again, 13. Carry 1, 9 and 8. 4 decimal places. 1, 2, 3, 4. Start from your right side. And 89.3979. Let me lower that. And oh, no. Here we go. What is 339? And again, I'm going to, let's start here. 39.34. That goes inside, divided by 1.5. Move on over and multiply by 10 to get me 15. And multiply that by 10. I'm going to multiply the inside by 10. And that, or move one over, it means the same thing. It gets me to 39.34. 15 goes to 39 twice. 9 left over, bring the 3. 15 goes into 93 6 times. And that's a 90. Subtract, that's 3. Bring the 4 down. 15 goes 34 2 times. 30. Now I'm going to continue because it says round to the nearest hundred. So I'm going to go add a decimal, bring a 0. 4 minus 0 is 4. I'm going to bring that 0 down. 15 goes to 40 2 times. 15 goes 2 times, that's 30. 10 left over. I'm going to bring another 0. So 15 goes to 106 times, which is 90. Okay, and then because I want to round to the hundreds place, I'm going to go 3 decimals. 10, I'm going to bring one more. Okay, and that's 100. And 15 goes to 100 6 times again. So now I can round. So now that I have my answer as 262.266, I can round to the nearest hundred. And to round to the nearest hundred means I'm going to cut it right here. Okay, so it's going to become 262.2, and this 6 is definitely going to move that 6 higher. Final answer, 262.27. The sets, it's not a counting, so remember we have the counting, we have the whole numbers, we have the integers and the rationals. So 12.5 is not counting, it's not whole, but it's not an integer, it's just rational. Negative 8,374 is not counting, it's not whole, but it is an integer. And it's rational. Negative 8.43 is not a counting number, it's not a whole number, it's not an integer, it's just rational. And last one. Place the following number line. Yikes. Okay, so let's do that. It's okay. Let's see. 0. They're all negatives, so I don't need any positives. So let me start again. This is going to be 0. I'm gonna make my negative 1 a little big, and negative 2 all the way here. So that was the first number. 0.01. That's 1 penny. 1 penny is really close to 0. But since it's on the negative side, it's going to be on this side, and that's going to be negative 0.01. Negative 2/7, okay, change it to a decimal if you don't know its value, okay? And 2/7, it's about 0.28, 29, okay, rounded, so 0.29. If that's 1 penny negative, this is 2 pennies, 3 pennies, 4 pennies, 5, 6, 10, 15, 20, 29 should be about, maybe about here. Negative 0.29. $1 is between 1 and 2, and that's right here, right after the 1, negative 1.01. 1 and 1/8, okay, 1/8 is about 12, so that's going to be not too far, and I'm going to bring that a little down. Okay, so it's negative 1.12, and I'm going to put it right here, negative 1.12. Okay, still very close to 1. Negative 7/8. I know this one. Okay, it's going to be close. Let me just erase stuff. Sorry. 7/8 is between 0 and 1. So if I have to 7/8, it's going to be closer to negative 1, between 0 and 1. And that's going to be about 0.87. So between 0 and negative 1, closer to negative 1, and about, so 10, negative 10, 20, 30, 40, 50. 50 is in the middle. Negative 60, negative 70, negative 80, and about 87, right about here. Negative 7/8. Okay. And that's it. Okay, so this will be uploaded pretty soon.